Welcome to the deep dive. We're here to really unpack complex topics, getting right to the heart of the source material you bring us.
Absolutely.
And today we've got something I think is, well, pretty transformative on the table. We're looking at how an AI can actually interact with and control smart devices, the things around us, making our environments genuinely intelligent.
That's the goal, yeah. And the core idea making this possible, the real linchpin here, is something called Model Content Protocol, MCP.
MCP, okay.
Think of it like a universal translator, or maybe a bridge. It's the language that lets the AI brain discover what's out there, understand it, and then actually command smart tech.
So it's more than just connecting A to B.
Oh, definitely. What's really key about MCP is how it lets the AI autonomously find and use new tools, new devices, new capabilities without needing a human to constantly recode it.
Adaptability.
Exactly, which you absolutely need for, the real world. Things change.
Right. And our source material for digging into this, it's quite specific.
Yeah, we've got 2 Python files. They're essentially the heart of a demo smart home system.
MCP client Gradio-UI.py and MCP server home automation.py.
Those are the ones.
So the plan is break down what each file is doing, see how they fit together, and really show how MCP enables all of this, turning code into concepts you can grasp.
Sounds good.
Well, Lazarus,
Let's jump in.
where do we start? The brain.
Let's start with the brain, yeah.
Yeah.
The user-facing part, that's the MCP client Gradio-UI.py file.
Okay.
Its main job is to be your AI assistant. So it take your commands, when you type or say, turn on the living room light.
Or set the thermostat warmer.
Exactly. It takes that natural language and then figures out, okay, how do I actually get this done?
So you mentioned user-facing. How does someone, interact with it easily if they're not a coder? What's the interface like?
Good question. That's where a library called Gradio comes in. It's Python-based.
Gradio.
Yeah. And it's brilliant for quickly building web interfaces. Think chat boxes, buttons, simple, clean.
So developers can focus on the AI and MCP part, not get bogged down in web dev.
Precisely. It lets you get a working UI up fast, making the AI assistant really accessible.
Okay, so we have the interface. What about the smarts? The part that understands turn on the light.
That's powered by Azure OpenAI, specifically a deployed large language model.
Leveraging a big gun.
Right.
Yeah.
No need to build a language model from scratch for a demo like this. You use a powerful pre-trained service.
And its instructions are basically use tools.
Pretty much. Its core directive is use the tools you have available to answer questions and help the user control their smart home.
Okay, use the tools you have available. That sounds dynamic. How does it know what tools it has? Is that list fixed?
That's the really clever bit. It's dynamic tool discovery.
Okay.
The client connects to the other file, the MCP server home automation.py, which acts as a kind of tool library.
Right, the second file we mentioned.
And here's the key. The client only gets that list of available actions, controlling lights, setting temperature, whatever, when the server is actually running.
Oh, interesting. So if the server's offline.
The client knows. It knows it can't do those specific smart home tasks. It might offer general help, but it won't pretend it can control the thermostat if the thermostat tool isn't available.
That makes sense. It only promises what it can actually deliver at that moment. Does the client, can it even control if that server, that tool library, is running?
It can, yeah. The client code actually includes functions to start and stop the MCP server process itself.
Wow, okay, so it can effectively bring its own tools online or take them offline. That's flexible.
Very flexible. It's a key aspect.
And you mentioned context earlier. If I say turn on the light, pause, then say now make it brighter, how does it keep track?
Right. Conversation memory. There's a function in the client, process user input, that's designed specifically for that.
Okay.
It makes sure the AI remembers the history of your chat. So when you say make it brighter, it understands you're still talking about the light you just turned on. Makes it feel much more natural.
Yeah.
Much less robotic. Okay, so the client is the smart interface. Figuring things out, remembering the chat, dynamically finding tools. But where do those tools actually live? Where are the capabilities defined? That must be the server file, right? MCP server home automation.py.
Exactly. Let's shift focus to that one. This is the tool library.
The command center.
Kinda, yeah. It defines all the possible actions the smart home can perform. And importantly, it keeps track of the current state of all the demo devices.
Right, demo devices. This isn't controlling my actual house lights.
Correct. It's a simulation, which is great for development, right? You can test things safely without messing with physical hardware.
Makes sense. So how does it store the state of these simulated devices?
It uses a simple Python dictionary called devices. Think of it like a status board.
Okay.
It holds entries for, say, living room light, thermostat, front door, and stores their current state like on or off, the temperature setting, locked or unlocked. Simple enough. Now, the crucial part. How does this server tell the AI client, hey, here are the specific actions you can ask me to do?
That's done using something in MCP called decorators. Specifically, at mcp.tool decorator.
Decorator, like a label.
Exactly like a label.
Yeah.
You put this at mcp.tool, tag right above a Python function in the server code.
Okay.
And that tells MCP, this function here, it's a tool. Make it discoverable and callable by an AI client.
So you'd put that on functions like list devices or control light?
Precisely. Functions like list devices, control light, set temperature, control door lock, even one called activate a scene, they all get tagged with at mcp.tool.
So if I ask the AI what devices are on, it knows, because of MCP, to look for a tool like list devices on the server.
Yes. It discovers that tool's available, calls it, the server runs the function, gets the statuses from that device's dictionary.
And sends back a neat list.
Exactly. Sends back a formatted list, which the AI can then present to you.
Okay. And control light, what can that do? Just on off.
It's pretty flexible. It can handle on, off, toggle. And it can also take an optional brightness level, say 0 to 100.
Ah, nice.
When it's called, it updates the state in the devices dictionary, sets the light to on, maybe brightness to 80, and then sends back a confirmation message.
Like, okay, light is on.
Yeah, something clear, like living room light is now on. Same idea for set temperature and control door lock.
You also mentioned activate fee scene. That sounds potentially powerful, more than just one action.
Yeah, that one's pretty cool. It lets you bundle multiple actions into a single command.
Oh, right. Like a good night routine.
Exactly. You could say activate evening scene, and maybe that one command tells the server to dim the lights via control light, adjust the thermostat via set temperature, and lock the door using control door lock, all at once.
That's much more convenient than saying 3 separate things.
Definitely elevates the experience. It orchestrates things.
Okay, so at mcp.tool marks callable actions, but I see there's also at mcp.resource used with something called getDeviceStatus. How's a resource different from a tool?
Good catch. A resource in MCP is more about providing data for the AI to read rather than an action for it to perform.
So read-only access.
Essentially, yes.
Yeah.
The getDeviceStatus function, marked as a resource, provides the raw state data, usually in JSON format, of all the devices and maybe recent events.
And why would the AI need that raw data?
It could use it for context, maybe to generate a more detailed report for you, or even for some internal reasoning, without actually changing anything in the smart home. It's about getting information without triggering an action.
Okay, that makes sense. Tools do things, resources provide data, and there's one more decorator at mcp.prompt with home status prompt. What's that about? Guiding the AI's response.
Precisely. Think of it as a template or a set of instructions for how the AI should present certain information.
So like controlling the output style.
Exactly. The home status prompt basically tells the AI, okay, if the user asks for a home status report, first you should probably call the list devices tool to get the latest info.
Right, get the facts.
Then present that status, maybe add some helpful suggestions, mention any security alerts, and do it all in a friendly conversational tone.
Ah, so it ensures the AI gives a consistently helpful and well-structured answer for common requests.
That's the idea. Consistency and helpfulness in the output.
Okay, I think I'm getting a clearer picture now. We have the client, the AI brain, the interface talking to the server, the tool library, the state manager. Let's walk through an example to really nail it down.
Sure.
Imagine I type into that Gradio chat interface. Turn on the living room light. What happens step by step?
Okay. Step 1. The client file, MCP client Gradio-UI.py, gets that message.
Right.
Step 2. The AI agent inside the Azure OpenAI part processes turn on the living room light. It understands the intent is control, the action is on, and the target is living room light.
It parses the request.
Exactly. Step 3. The AI knows, because it dynamically discovered the tools from the server,
When it connected earlier.
that there's a control light tool available. So it decides to call that tool. It sends a request to the server saying, essentially, call control light with parameters. Device, living room light, action on.
Got it. So it sends the instruction over.
Step 4. The server, MCP server homeautomation.py, receives this call. It finds the control light function because it was marked with at mcp.tool. It executes the function. The function updates the device's dictionary, changing the state for living room light to on,
Flips the virtual switch.
Flips the virtual switch.
Right.
Step 5. The server's control light function finishes and sends back a response, usually a success message.
The living room light is now on message.
Right. Step 6. The client receives this confirmation message from the server.
And finally,
It displays that message back to you in the Gradio chat window. Done.
wow. Okay, when you lay it out like that, it's a clear flow. The client figures out what to do, the server does it, and MCP is the language they both speak to make it happen.
You got it. MCP is that essential translator, that standardized protocol. It lets the AI brain discover and use the limbs, the tools provided by the server.
It makes the AI so much more than just a chatbot. It becomes an orchestrator, an agent.
An agent is a great word for it. MCP enables AI agents to interact meaningfully with external systems, data, and tools. It's the foundation for making AI genuinely interactive and useful in broader contexts.
So these two Python files, they're not just code. They really create this mini ecosystem powered by MCP where an AI can understand, act, and report back.
It's a fantastic practical example. It shows how AI can move beyond just processing information to actually doing things, even if it's in a simulated world for now. It shows the shift from AI as passive responder to active agent.
Yeah, that distinction feels really important, active agent. Which brings us to the wrap-up, thinking about this. If an AI can dynamically discover and use a tool library for a smart home, well, what does that imply for the future?
It opens up huge possibilities, doesn't it?
It really does. What other libraries of capabilities could an AI tap into? Financial tools, scientific instruments, creative software. How fundamentally could that change how we interact with technology, everywhere in our lives?
That's the big question to ponder. If any capability can be exposed as an MCP tool or resource, what can't an AI potentially learn to interact with?
A fascinating thought to leave things on.